Morning, guys. Today we're going to continue on with some organic chem. Last week I kind of introduced functional groups, the names of those functional groups, and then how we name molecules with those functional groups. Today we're going to flip the script and kind of reverse what we're up to. We had previously been given the picture of a molecule or the structure or shape of that molecule, and then I'd asked you to name it, right? So that was all what we did last week. But today and this week, we're going to do the opposite. We're going to give you the name and actually draw these molecules, which is obviously just the same thing but in reverse. But I don't know, it's a little tricky. It's got its own pitfalls, and obviously we need some practice doing it. So I have 24. I think it's 24. Let me check. 26. Sorry, examples on this page. I'm going to go through the first 12 today. I'll go through the next. I can't do math. 14 tomorrow. And then we'll do the same thing. I'll have a little assignment that'll be due at the end of the day, Thursday, and then we'll call it a school year. So I hope this little organic stuff, if you're following along, has been kind of fun. I obviously enjoy it, but that's just me. Anyway, so we'll start today slow. We'll give you a little taste of how to draw these things out. What I'm going to be doing is I'm going to be using a program called MoleView, and it's a free program, moleview.org, and you can actually draw molecules on here. So I'm just going to be having this kind of side by side, and I wish I could, maybe not side by side. I'd love to close that, but I don't know if I can close that. Either way, okay, that's fine. But I'll be flipping back and forth between the sheet, the name that I'm trying to draw out, and then I'll be making that in MoleView right here, and then we'll maybe copy and paste it somewhere else. Yeah, let's do that actually, we can do that. Sorry, teaching on the fly. Yeah, that'll work well. Okay. Sweet. So, first one here is heptane. Heptane, we look at that name, and what we see is the prefix hept. That's not working. Hold on. Neither is that. There we go. So, prefix hept is implying 7, and then the ane ending is just a normal alkane, meaning a singly bonded chain of 7 carbons. Nothing special here. No functional group, nothing to worry about, no oxygens, anything like that. So the way we draw this is like this. Okay, I'm going to see if I can get rid of the carbons. There we go. So I can go 1, 2, 3, 4, 5. Ooh, that's an ugly one. 5 and 6. Now I said 6, but what happens here is if I draw 6 lines, I end up with 7 carbons. So every little end is a carbon, and every intersection is a carbon, right? So I have 1, 2, 3, 4, 5, 6, 7. That's a little bigger. And then I'll just copy and paste this where I want it. Ooh, that's an ugly sound. And that's heptane. Now, you could use the C's and the H's, obviously, if you wanted to. You're more than welcome to include, all the C's and all the H's. But really, these little lines, these segments, and again, every end and every intersection is a carbon. It's a little quicker. It's a little easier. And, sorry, I just cut out. Hopefully that wasn't too clunky. Anyway, let's go to number 2. Number 2 is 3-hexyne. The prefix there is hex, so we know we have 6 carbons. The suffix is yne, Y-N-E, which implies a triple bond. Now, where does that triple bond go? It goes on the 3rd carbon, hence the 3 in front of that name. So if I were to draw 3-hexyne, it should look something like this. I'm going to first draw 5 line segments, and I'm going to be I'll do this a couple different ways to show you what I mean. So, 1, ooh, gosh darn it, struggling. 2, 3, 4, 5. Now again, when you draw 5 segments, that equals 6 carbons. You always get one more than the number of segments you draw because of the end of those lines. So this would be 6, and if I want a triple bond at carbon number 3, I would go 1, 2, 3, and I could make that right there. But there's one problem with the way I've drawn that. The bond angles around a triple bond are linear. So this little angle that way and this angle downward are actually incorrect. So I'm going to do this slightly differently. I'm going to go and keep this linear right there over that section. So 1, 2, 3, 4, 5, 6 carbons. I should have 6. 1, 2, 3, 4, 5, 6. Perfect. And I'm going to make a triple bond right there. So I have my 6 carbons. 1, 2, 3, 4, 5, 6. I have my triple bond on the third carbon. 1, 2, 3. That's where it starts. And I'm showing the appropriate bond angle. So this is a better structure. If you didn't make it linear, I wouldn't lose sleep over it by any means. But nonetheless, I figured I should show you the correct way of doing that. So, oops, wrong page. There we go. So that's 3-hexyne. The next one here, we have 4-octanol. Let's clear my slate here. So oct implies we have 8 carbons. And all, the ending OL implies that we have an alcohol. So if we have an alcohol, that's an OH group. And that shows up on our 4th carbon in our chain. That's why the number's there. So I'm going to have 1, 2, 3, 4, 5, 6, 7, which is going to give me 8 carbons. Again, 7 segments, we get 1 more carbon. And then I have an OH group coming off of the 4th carbon on my chain. So 1, 2, 3, 4. Off of that, I'm going to have an oxygen and a hydrogen to make an alcohol group. So it's going to look like this. 4-octanol. We'll just copy and paste that over to the one. And there it is. Oh, we got the highlight. That's all right. Prop and amide. Prop is implying 3 carbons. Amide at the end is implying a nitrogen and oxygen group. So just for the sake of argument, because again, it's been a little bit, and this was last week, let's open up that other one, the old sheet, just to make sure that we're not screwing this up. And if I scroll down, I'm going to close this. Okay, and amide, that's the naming. Oh, I'm sorry, it's in my notes. Oh well. But an amide's going to look something like this. Okay, this one down here is an amide, where you have a carbon chain, you have an oxygen and a nitrogen off of that last carbon on that chain. So it's actually this structure, spoiler alert. That's okay, we'll draw it in here. So I have 1, 2 segments, which gives me 3 carbons. Again, we had prop. So off of this 3rd carbon then, we have an amide. So I'm going to get a doubly bonded oxygen, and I'm going to get a nitrogen group. Now, that nitrogen group is really going to be, oops, we would need to fill out nitrogen's bonds. So again, there are some hidden hydrogens over here as well. There should be 2 of them, and there should be a lone pair on this as well. Again, I'm not going to lose too much sleep over that. I'm more concerned about you getting the correct number of carbons in the chain, the correct positioning of the functional group, and obviously labeling the functional group. It'll look something like that. And again, you can see how I started upward with this first carbon. I could totally have started downward, right? Like, so the oxygen, double bonded oxygen could be going upward, the nitrogen could be going downward. You can invert and flip this whole thing or mirror image this whole thing, and that's perfectly fine too with your structures. Pentanoic acid, implying we have 5 carbons. So let me draw 4 segments. 1, 2, 3, 4. I have 5 carbons. Pentanoic acid, that's a carboxylic acid is what the functional group is called. What that means is off of the last carbon in your chain, you're going to have a doubly bonded oxygen, and you're also going to have an OH group. So it's going to look something like this. 1, 2, 3, 4, 5 carbons, double bonded oxygen, OH group on the last carbon of that chain, which is a carboxylic acid. So this is pentanoic acid. There you go. Keeps highlighting things, that's okay. Triethylamine. This one's a little funky. Triethylamine implies that we have 3 ethyl groups off of an amine. Well, an amine is a nitrogen, so this is a nitrogen in the center with 3 ethyl groups coming off. So there's 1 ethyl group, there's 2 ethyl groups, and there's 3 ethyl groups, something like that. Okay? 2 carbon chain, 2 carbon chain, 2 carbon chain, nitrogen in the middle. So triethylamine, there's my 3 ethyls. Amine implies the nitrogen. That one's a little funky. I didn't really show you an example like that last week. Number 7. So I'll let you stare at that for a little bit if you need it. Number 7, 3-chlorononane. Chloro is implying chlorine. We have never done that yet either, so I'm sprinkling in some extra stuff just for fun. But I hope that's fairly obvious, right? If you see bromo, that would be bromine. Chloro, fluoro, I mean, they're all implying chlorine, fluorine, oxygen, or sorry, chlorine, fluorine, and bromine, obviously, so that's perfectly allowed. So a 3-chloro-nonane, non is the prefix for 9, so we would start there. So I'm going to have a carbon chain of 9. 1, 2, 3, 4, 5, 6, 7, yuck, and 8. So again, 8 segments gives me 9 carbons. And then I want to have a chlorine on the third. Okay, so there's my chlorine. 1, 2, 3. Boom. There you go. 3-chloro-nonane. Oops. There we go. Kind of severed that right there, but that's okay. Decene, I'm sorry. Decene is implying that we have 10 carbons with the prefix dec. And then ene is implying we have a double bond. There's no number. So if there's no number, that means that our double bond just happens on carbon number 1. I've lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And then we have a double bond. Ooh, okay. Right there, at the very first carbon. If there was a number, then our double bond would be somewhere else. But without the with the absence of a number, it's just implying that we have it on the first carbon. Let's transfer this over. And cycloheptane. Cyclo, that means a ring. Heptane is implying 7 carbons. So we have a 7-membered ring. And I'm going to have a heck of a time drawing this. Ha, never mind. They got one for me. Boom. Totally cheated. Drawing a 7-member ring is not easy, but obviously it's just a 7-sided, shape. So thankfully I didn't have to do that freehand. I think that would have ended well. Looks like that. Ethyl hexyl ether. So an ether is where you have an oxygen in the middle of your carbon chain, and you name both sides. So one of our sides on the opposite side, or one of the carbon chains on one side of the oxygen is 2 carbons long because of F. The other carbon chain on the other side of the oxygen is 6 carbons long because of hex. So what we have is 8 carbons in total with an oxygen after the second carbon. So two carbons on one side, 6 on the other. So let's go. Ooh, come on, turn. There we go. So that's 1, 2 carbons. That's the ethyl part. I have an oxygen in the middle to give my ester. And then I'm going to have 6 carbons on this side. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Just making sure. And this would be ethyl hexyl ether. Two more for today, and then I'll leave you guys alone until tomorrow. Methyl pentanoate. So that O8 ending is implying an ester. So again, we have ethers and esters. Let me go back real quick. Okay. So an ester, you have an oxygen in the middle of your chain, and oh my gosh, I'm screwing this up. An ether is when you have an oxygen in the middle of your chain, singly bonded. An ester is when you have an oxygen singly bonded in the middle of your chain with a double bonded oxygen right next to it. So I'll give you the 2 examples that we had from the previous. Actually, I didn't have a ester in here, did I? I only had the ether, I believe, if I remember right. Yep. So there's your ether, right there. And then the ester, I wasn't on the note sheet. I think I did one on my note sheet, but I didn't give you guys one on your page. So either way, so we're gonna do an ester now, which gets that weird ending, that O8 ending. So the first name, or the first part of that name, let me go back, methyl, is going to be on the side without the double bond. So the singly bonded oxygen side of that chain gets named first. So that's our methyl side. So let me start there. So I'm going to have 1 carbon on the side of the singly bonded oxygen. So I'm going to go like this. So there's my carbon, there's my singly bonded oxygen. On the opposite side of that single bonded oxygen, I have the other side of my chain, which has a double bonded oxygen right next to it. I then need to finish this. How many did I have? Pent. So 5. So 1, 2, oops, don't do that, 3, 4, and 5. 1, 2, 3, 4, 5. So methyl, pent, a noate. A noate is implying this ester configuration right here. So again, an ester is single bond, double bond oxygen in the middle of your chain, right next to each other. So again, this side gets named first, the single bonded oxygen side gets named first, methyl, pent, a noate. And let's copy and paste that over to the other presentation. There you go. One more, 2,5-octadione. So we have two numbers, which means we have two functional groups on this chain. We have oct, which is implying 8, and then we have dione. So one is a ketone, which is a double bonded oxygen somewhere in the chain, in the middle of the chain, and di is implying 2 ketones. So one of those double bonded oxygens will show up at carbon number 2, the other one will show up at carbon number 5, and it's going to look something like this. We have 8 carbons, so 1, 2, 3, 4, 5, 6, 7, which will give me 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. And then I have a double bonded oxygen, no, it won't let me do both, at carbon number 2 and carbon number 5. So 1, 2, 3, 4, 5. And that is 2,5-octadione. Essentially, again, like you're kind of breaking down obviously what you're given, right? You're given prefixes, you're given numbers, and then somewhere in the name, you're kind of implying what type of functional group is going to be there, right? So you just figure out what you got. It's kind of fun. It's kind of enjoyable, I think. But anyway, so I'll save this and I'll share the answers with you as well. But please, obviously, give this a thought, and then tomorrow what we'll do is we'll jump back in and finish the rest of these, and then I'll give you a little quiz, like I said from last week too. And when I say quiz, obviously I don't really actually mean quiz. It's sorry, cut out again. I don't know what's going on with my screencast today, but anyway, so when I say quiz, I obviously don't mean like a real quiz. This is very much just something for you guys to try to do to finish out the school year here. So anyway, I appreciate your time. Thank you guys, and have a great day. We'll catch you tomorrow.